I am super excited about this build for two reasons. One, I've never used a Raspberry Pi, so I'm looking forward to doing that. And two, I think this is going to be a lot of fun to play with, even as an adult. So the plan here is I'm going to take this blaster, which is electrically driven, which is awesome. That means I can hack into it and control it directly from my Pi. Using the Pi, going to this camera, if it detects a face, I'm going to be using this servo driver, this servo. I got a few motors, and I'm going to figure out some type of mechanism to allow me to pan and tilt so that I can line the blaster up with the nearest target that I could find. And then once it's there, it will start firing. All right, I got my Pi set up. It was a little bit tricky at first getting it on the network and then getting all the code system flashed. But once I got past that, I was installing all my libraries and everything turned basically into a plug and play. AI is a huge help if you're trying to get yourself experienced with this. The ribbon cable plugs straight into this camera. The camera I haven't mounted or taped right now to this servo motor so I could practice and see some face detection. And then now the servo driver back here, or the motor driver, this currently is powered by my Pi. That will not be the final version. You absolutely have to have a secondary power supply for that because once it goes under load, it's going to need a lot more power. But this works perfectly for testing. So you're going to see this motor kick on and move around. There we go. It's been acknowledged. Now, when I come over here to this screen, this is the monitor showing what the servo motor sees or what the Pi sees. And as I back out, you're going to see my face appear. And then when it gets the green screen, it's going, or sorry, the green square, it recognizes a face. It's going to move the camera towards me. I made these drums, and the way that I made these drums is I wanted to be able to slide this element directly into this. And in theory, I'd be able to continue to use this tripod. The problem was, I should have known better. This is less than 1/2 pound. So when you put any type of weight on it, I then experimented with just taping this thing straight to a 5-gallon drum. This definitely helped keep it steady. So when I mounted everything in place, everything worked from there. But then the next issue still happened is wobble on the barrel itself. And I'll show you what I mean. The original idea that I had was I wanted to mount the camera directly to the nose of the barrel so that way as it's looking, it was the best line of sight. The issue with this is that when you have any form of wobble like this, so if it turns and then there's a little bit of a wobble, that means that the face recognition software, it's going to take a little bit longer because the screen's bouncing around, so it's not going to be able to lock on a target. So what I'm considering doing now is to mount the camera to the bottom of the drum and let the barrel itself swing independently. To attach everything is I printed out this system where it has the internal gear. So this would sit here. We have the servo motor inside with the gear. So as it turns, this will pivot directly on top. Now these arms go straight through this hole right here. And then they meet in the middle. So as this stands, this is how the blaster or the Gatling gun will just stay. And then these two little legs pop straight into this round center. I made a very, very tight tolerance. There we go. And once that's in place, the Gatling gun now can sit and rest. This is how I was able to move the center of gravity. I put these arms, I had to bend them that way so that way everything hangs. And then once this is hanging in that position, this then can sit. This then can rest at this position. So the center of gravity is not the same issue once you have everything mounted, but wobbling absolutely is. So to move forward with this design, we have to scrap, unfortunately, the tripod. I'm going to be replacing my original prototype of black, and I'm going to be moving it to this blue color. I have a suspicion I will be building 2 of these, and I wanted to make sure that I can have opposing teams. We got to have the kill switch. So the concept behind here is I printed out this little device with a locking push button. And you gotta just twist it to unlock it. I made the tolerances very, very tight, so that way the target piece just slides directly in front of the target. And then once it's here, if you hit anywhere on here, you can hear that switch click, and now this is loose. You pull it out, unlock it, slide the target in place. There's enough friction that does not fall anywhere, and all you gotta do, just hit it once, and then you can reset it. This is gonna get mounted to the top of the blaster. So that way, as the lion's looking at you, you have a small target to hit. If you can shoot that target, it's going to disable the Gatling gun. Now, the last thing, you might want to make this bigger. We'll see through experimentation.
But this also led me to realize that placing the camera on top of the barrel, second critical flaw in the design, because I don't want to destroy that. So the plan now is I'm gonna make some modifications, lower the camera down to below here, alter the code so that way it's not controlling the y-axis to look for the picture, but instead making the logic based on the fact that it is stationary itself. I did a quick wiring here. I got my kill switch going through my relay, and then I'm short circuiting the switch over here for the triggering mechanism. This is just enough just to get me out there and to run a live firing test. I think I got it.
Yes, killed it on that shot.
With the prototype working great, it's now time for the final assembly. So in front of me, here are all the components that are used in this build. We're gonna go ahead and start building it all right now. Now the gear assembly should be installed like this, with everything mounted on the bottom side. Now this slot right here, this is where we're gonna be putting the motor driver for the servo motors. So that will slide in place right there to keep it nice and fixed. One part that's a little bit tricky about this build is you have to have all of your wiring going through the top of the drum. So I have this arm right here with the servo motor already connected because I got to run the wiring through so I can plug it into the motor controller directly. Once you have everything in position, then you can flip the drum over and then start buttoning it up. And then the last thing I realized is that when playing a bit rough, this top part can become disconnected. So I made a C-clamp here. So you'll need to make sure that you tap this for whatever screws that you're using. But these two components will go around on the back side. And then there's this clip that you will be putting above the relay port here. All right, the general assembly is done. Now all I gotta do is finish cleaning up this wiring to make it more permanent, and then we're ready to do the final testing.